77 minutes. No more than that. All right, so trig 2, you guys remember doing proofs last year? No. Well, we're going to be doing proofs this year. Yeah, you did proofs. We were just talking about it at the department meeting yesterday. Okay, so that means you have to know identities now. What identities are you responsible up to now? Well, first, the even odd identities. So, I think I wrote this on the board last time, yeah? Cosine negative x equal cosine x, because it's an even function. Sine of negative x equal negative sine x, because it's an odd function. Tan of negative x equal negative tan x, because it's an odd function. And then, of course, what was the one most important identity your teacher told you last year? If you could just remember one, which one is it? Cosine squared x plus sine squared x equals 1. That's probably the most important identity we have. We call this the Pythagorean identity. In fact, let me just show you a quick derivation of it. So if you have a unit circle and then you have any angle here, what are the coordinates of this point again? Cosine is the x and sine is the y, right? So therefore, isn't this cosine and this sine? And this is the unit circle, so the radius is 1. And what happens when you apply the Pythagorean theorem? You get this. That's why we call it the Pythagorean identity. But remember last year there were two others? Do you guys have those? And some of you are writing these down. These are all in there on the notes. There's an identity page. It's right there. You don't need to write these down. Okay, let me show you how to derive the other ones. What happens if you divide through by cosine squared? Divide that by cosine squared. Divide that by cosine squared. Divide that by cosine squared. And then you have another one. So this is another Pythagorean identity. To derive the other one, simply divide this one by sine squared. So divide that by sine squared. Divide that by sine squared. Divide that by sine squared. So these are all the identities that you have to know up until now. When we hit trig 3 though, then we're going to start learning more. Remember the sum and difference identities? Double angle, half angle. And then of course then you got to know all for the rest of your math career. So what we're going to do today is we're going to do a proof. There's a good one in the examples. There's examples. Come on, man. If you guys don't know there's examples, you haven't been looking at it. So here, chapter 7, trig. Look at the beginning. Look at all these examples. In fact, let's see. Look, right there, the trig identities. What are you talking about, Willis? Okay, right there. Prove the identity. Okay, so why don't we just go through this proof since some of you don't even look at it. You know, if you ever get stuck on a problem, maybe you should look at this, because maybe you can get something out of it there. So we're going to prove, oh gosh, I can't even see it from this far. Cosecant x plus 1 all over cosecant x minus 1 is equal to secant x minus tangent x quantity squared. Is that correct? Oh, plus. Okay, so how do we prove this? Does anybody remember anything from last year? You gotta draw the line. Does that sound familiar? Who calls it the Iron Curtain? Mr. Rubash? What about Mr. Cropsey? What does he call this line? A line. Okay, so here are the rules. You can work on the left side, you can work on the right side, you can work on both sides. But your goal is to get the left side equal to the right side. And if you can show the left side comes out equal to the right side, that means this is true. This, and by the way, we're trying to prove an identity. What is an identity? An identity is a statement that's true for all values of x, in the domain, of course. Now, you cannot do this. You cannot assume they're equal because we're trying to prove they're equal. So that's why you have to draw the bar. You cannot just put an equal sign and say, oh, I'm going to multiply both sides by the least common denominator. No, because that would be assuming it's true. We're trying to prove that it's true. So that's why you have to work on both sides separately. Okay, so here we go. What do I do? What did your teacher teach you last year? If you get stuck, and as on the harder ones, you are going to get stuck. So what should you do if you get stuck? A, skip to the next problem. B, take a laxative. C, change everything to sine and cosine. Ah, that sounds familiar, Mr. Park. Yeah. So if you ever get stuck in a proof, and like I said, the harder ones you usually are, change everything to sine and cosine. So like, what is cosecant? 1 over sine. 1 over sine. See, you might get a point for that. But then you got to do that to the right side too. Well, let's just work with the left side for now. Complex fraction. How do you simplify a complex fraction? Multiply top and bottom by the LCD, which is sine x. So multiply the top by sine x. Multiply this by sine x. Multiply that by sine x. Multiply this by sine x. Multiply that by sine x. See, you got this. See, kind of nice, right? Okay, now what about the right side? So now you really kind of stuck again, so maybe I should work on the right side. So what can I do? Should I just automatically change everything to sines and cosines? Or just square it right now? It's up to you. I mean, there's an infinite number of ways of doing a proof. I'm not going to look for any like efficiency or anything like that, so as long as yours works, good enough. So what would you do if you have something like this on a quiz? Change it to sines and cosines or square it right now?
Square it.
Square it right now. Okay, let's do it. So secant squared x, and I hope you guys know, secant squared x means secant x, quantity squared, right? That's what it means, except that's just the way we write it in mathematics. Okay, plus 2ab plus b squared. Okay, now what?
Change the sign.
Now change it to sine and cosine. Okay. So 1 over cosine squared. Well, that's kind of a good idea because look over here, it's only sine, right? So that's probably what you're going to do. Plus 2 times 1 over cosine times sine over cosine plus sine squared over cosine squared. And then what do you think I'm going to do when you add fractions together?
Multiply.
Least, no, you cannot multiply now.
Oh.
You cannot go 1/2 plus 1/3. Oh, just multiply by 6, 3 plus 2. So you're telling me 5/6 is equal to 5? No, you cannot do that. You can make a least common denominator though. What would go on the top? 1 plus 2 sine x plus sine squared x. So after doing this, I think we should have changed it to sine and cosine before we started. We're going to do all this. I mean, same thing. Okay, now look. Well, if I'm going to make this equal to this, I got to change everything to sines and cosines. Well, the top is sine. Is there anything I can do with the top? Look at it. 1 plus 2x plus x squared. That's a perfect square, isn't it? Isn't the top a perfect square for? Really? 1 plus sine x. Now what about the bottom? Is there a way I can change cosine squared to sines? Yes, look at your Pythagorean identity. What is cosine squared x equal to if you just move this on this side? 1 minus sine squared. Come on, you guys did that a lot last year. Hey, now I got everything with sines. This is all sines. All I gotta do is just do some algebra and it should come out, right? The answer is yes. Hey, this is a difference of squares. So can't I factor it? This is like 1 plus gorilla squared. So 1 plus gorilla times 1 minus gorilla. And then look, I can cancel this with one of that, so then I have this. And this is just one way of doing it. Like I said, there's an infinite number of ways of doing it. So is the left side equal to the right side? Yeah, so what do we write when we finish the proof? And don't say happy face.
0.
If anybody writes a happy face, that's just a fatal error. Maybe when you first learn it, your teacher wants you to because you feel like you accomplished something. So what happens if you don't finish it, put the sad face? What did you do last year? No, what happens when you finish a mathematical proof? Come on. QED. Look, it's in the example right there, look, QED. That stands for quad. How many of you take Latin? Oh boy. Quad erat demonstrandum. Demonstrandum. That means that which was to be proven. So you only write this if you finish the proof now. Do not dare to write this if you don't finish the proof. Okay, so here, to make it easier, some people just remember quite easily done. How's that then? That's not what it stands for, but. Okay, so that would be an example of a medium level proof, but of course, we're in honors, right? So you might get some that are a little tougher. Okay, and then the last thing, we only have 6 minutes left. We'll try and do as much as we can. The last thing you gotta know for tonight's homework, well, if you started, because remember, it's either catch up or get ahead, is solving equations. This is like probably the most important thing of this chapter. Can you solve equations with trigonometry in there? Okay, let's start easy. 2 sine x equal 1. How do you solve this? Now, if you don't know your trig values, you won't be able to do this. So what do? Divide both sides by 2, okay? Sine x equals 1/2. Now, is that a number I'm supposed to know for sine? Yeah. Okay, think of your unit circle. Where on the unit circle is sine, or the y coordinate, 1/2? Wouldn't that be like here and here? Here, let's think of this. Where is there? Huh? Pi over 6. And where is this one? 5 pi over 6. See, if you don't, that's why we have speed quizzes, because if you don't know your trig values, can you see how you're going to fail the rest of the quarter already? That's why teachers give you speed quizzes. But are those the only answers, or are there more? Yeah, there's infinitely more. What if you, okay, here's pi over 6. What if you add 2 pi to it? So 13 pi over 6? Right? What if you add another 2 pi to that? 25 pi over 6? So remember how your teacher told you to write this last year? Instead of just writing them all like that? What? Does this look familiar then? 2k pi. That means multiples of 2 pi, because every time you add or subtract 2 pi, you end up at the same place, right? So that's what this 2k pi is, where k is an element of the integers. Like, think about it. If k is an integer like 1, that means add 2 pi. What if k is 5? Add 10 pi. What if k is -3? Then subtract 6 pi. Anytime you add or subtract any multiple of 2 pi, you're going to get the same angle, the same place on the unit circle. However, when you go to calculus, whenever they give you a trig problem in calculus, they will always restrict it to between 0 and 2 pi. So in this class, you don't have to worry about the 2k pi. Mr. Parker never worried about it last year either. Okay, so that means when you solve this equation, you simply have to just tell me pi over 6 and 5 pi over 6. Good enough. Everybody understand? I'm only asking for answers between 0 and 2 pi. And that's because that's what the calculus people want. Okay, let's make the equations a little harder now. 4 cosine squared x equals 3. How would I solve this one? Okay, divide by 4. And then what? Square root both sides. What is the square root of this? Let's see if you guys remember anything. What's the square root of gorilla squared?
Absolute value.
Absolute value of gorilla. Thank you. And what's the square root of 3/4? Root 3 over 2. And of course, this means cosine x is equal to plus or minus root 3 over 2. I keep telling you guys that the plus or minus comes from the absolute value. Okay? Okay, now are these numbers we're supposed to know? Yeah. Cosine of what angle is plus or minus root 3 over 2? This is what I would suggest you do. Somebody gives you an equation, you go like this. See, on the unit circle, it's here and here, right? See, some of you don't even know your trig value, so that's why, what is he doing? I'm putting my arms on the unit circle where it's supposed to be, like here. See? So where is that? That's the pi over 6 family. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. You know why I can do this? Because I know my trig values, but that's why you guys better study. Because otherwise, I mean it, you really will fail every test for the rest of the quarter. And I'm going to do a lot of trig in the second semester as well. Okay, we got 2 minutes left. I'll do one more example. Oh, well, we're going to have to continue this anyway. Let's see if you guys remember anything. Tangent 2x is equal to 1. Now, is this a number I'm supposed to know for tangent? Where is tangent equal to 1? What is he doing? Where on the unit circle is tangent 1? Right there and there, right? Pi over 4 and 5 pi over 4. Everybody agree? But do you guys remember what happens when this is 2x? Remember what to do from last year? You got to go twice around the unit circle. This is just once around. So how do you go another time around? You remember? Add 2 pi to each of these. Why are we doing that? Well, add 2 pi to this, which is 8 pi over 4. Add 8 pi over 4. The reason why you have to go 2 times around is now, to solve for x, you got to divide by 2. So pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. So anytime you have like 2x, you got to go 2 times around. If it's 3x, you got to go 3 times around. 5x, 5 times around. Otherwise, you're going to miss solutions. All right, the bell's going to ring in less than a minute. Well, for those of you who want to get ahead, at least you have something you can that'll help you. We didn't quite go over the harder problems. I wanted to do 2 more examples, but you don't have to wait the next time. Or you can actually look at the examples. All right, I will see you on Thursday.